Rice cultivation in Guyana is rapidly increasing. While quantity is increasing, the quality too has to meet its required standard. And that's what the Quality Control Department of the Guyana Rice Development Board is mandated to fulfill. I'm Carl Gurusamy and welcome to the weekly edition of the Science of Rice. This week we zoom in our focus on the quality control aspect of rice production and its importance to both local and export markets.
The Quality Control Department of the Guyana Rice Development Board was established from an act of GRDB 1994. The department was formerly that of the National Paddy and Rice Grading Center, and in 1994, through the establishment of that act, the three entities at that time, the Guyana Rice Milling and Marketing Authority, the National Paddy and Rice Grading Center, and the Guyana Rice Export Board merged into what we now have as the Guyana Rice Development Board. And the National Paddy and Rice Grading Center became the quality arm of the Guyana Rice Development Board.
The Guyana Rice Development Board operates under a quality management system where a quality manual and 17 quality system procedures were developed. The laboratory is currently certified to the GYS 170 standard by the Guyana National Bureau of Standards. The scope of certification is the physical testing and moisture determination on rice and paddy sampled by the laboratory. The laboratory has gained certification on the 8th of July 2011. This certification was valid for 2 years. Subsequently, the laboratory was reassessed or re-examined and recertified on the 5th of August 2013. The laboratory participates from time to time in inter-laboratory comparison with its other regional laboratories. This is one, to assure that staff maintain their competency level and to ensure that when staff perform testing, grading, moisture determination, all staff can accumulate one factor or 1% moisture percentage or so. Now the training is being done, or we can say regular training is being done on the quality system, sampling, inspection and fumigation, aiming at staff competency. To ensure continued compliance of the management system to the GYS 170 standard, the laboratory is regularly audited by the Guyana National Bureau of Standards.
The main objective of the Quality Control Department of GRDB is to grade and certify paddy and rice received before it reaches the buyer.
The Quality Control Department also has as one of its main functions the production of the technical standards. This is to say all rice and paddy being certified has to be done through a technical standard which flows from internationally accepted standards. Now, the Bureau of Standards is ultimately responsible for all standard writing in the country. So we worked along with them to produce the standard that we now have, the GYS 211 standard. And the standard was updated this year. And I was part of the committee, actually the chairperson of the committee, along with other rice persons within Guyana, to establish this new standard. The standard has to be approved by the CARICOM regional standards body. So all the countries involved in CARICOM that are producing rice played a function in the establishment of this standard. So the standard is not basically something that one person took and wrote. It is a standard being approved by the Guyana Rights Development Board and the GNBS and finally CrossQ, and will be operated within CARICOM. The department also ensures that persons are trained within the industry to grade paddy and rice, and this is normally done through training programs held once or twice a year, and the persons are then licensed to operate. They have to take an exam. They're monitored during their performance at the rice mills to which they will be employed as a private person. If they do not operate within the rules and norms of the Guyana Rice Development Board, their licenses can be revoked. Their licenses are in place for 2 years, and after that 2 years, it's renewed. If they're still within the business, if we still find that they're competent. Any other functions that are issued within the rice industry by the mandate of the minister with respect to quality is conducted by the department.
All rice and paddy produced must be of a required standard, whether for local or international consumption.
One of our main functions is to ensure that paddy being purchased at mills conform to the standard, that farmers receive the quality that is defined according to this GYS 211 standard. And having said that, personnel from the offices are placed at rice mills, strategically placed there during working hours to ensure that the standards and the rules of the GRDB is maintained during delivery of paddy.
There are several labs across the major rice growing regions in Guyana. These are regions 2, 3, 5, and 6. The paddy or rice is tested there first before transported to the head office in Georgetown. Here, it is graded again to ensure the quality standards are accurate.
When rice comes to be certified and it does not reach a standard, we will have to reject it. We only accept rice that meets the standards of a contract. The contract is normally presented to the board and approved at the board level, and that is the only certificate that we can approve based on what the buyer requests. Anything outside of that will have to be approved by the buyer and meet specification also, because we have an agreement with CARICOM for the rice or paddy that we're sending to be within a specific specification. So anything outside of that cannot be sent, because we will be held responsible for that. So anything that does not meet the quality, it is normally rejected within the regions firstly, before it even enters to Georgetown to be exported. That is why the offices are out there.
While the department is working towards maintaining high quality paddy and rice, work is in progress of becoming internationally accredited.
The department is now involved in trying to have the laboratory, the central laboratory at Region 4, located here in Cowan Street, accredited to the ISO 17025 standard. We envisage that by the end of the year or sometime in January 2015, this will be completed.
The scope of which the laboratory is seeking accreditation is analysis of moisture in paddy and rice and grading of paddy and rice. The laboratory is presently benefiting from consultancy services in preparation for accreditation provided by CrossQ, Caribbean Regional Organization for Standards and Quality, under the CART Fund project. With accreditation come numerous advantages. 1. Competitive edge. Accreditation is an effective marketing tool of which provides a competitive edge during bidding and the acquisition of contracts. Two, we can gain customers' confidence in that when results are being produced, our results will not be questionable.
Now that we have an overview of the importance of quality control in rice and paddy production, this next segment will demonstrate the practical grading and certification procedure by qualified and experienced grading officers. First, we look at testing the moisture content.
This is an analysis of white rice for export. When the sample comes to the lab, it is being coded by the coding officer, and then it is given to the staff to be graded. The first thing you do, you break down the sample in your burner divider. You mix it 3 times, and then you take out a working sample of 35 grams. You make sure it is closed, and you make sure the pans are empty, because sometimes somebody might use it before and stuff leaving. You break down your sample 3 times. This is mixing the sample thoroughly. Two. Take one of these. All right. Put it back in the bottle. Now you're breaking down your sample into the working sample of 235 grams. Weigh out, this is 135 gram.
The same weighing is applied to the second sample. Each sample must be precisely 35 grams as seen in the demonstration. After each sample is taken, the remainder is tested for moisture content. Note, you can also test the moisture content too before dividing your working sample.
This is the moisture meter that we use in the central lab. According to this moisture meter, there's a bias on the meter. The bias is for the different types of rice. You hit a minus or you had your bias. This is the white rice I'm doing. So in the case of the white rice, you will minus 1.3. You pass your rice through the moisture meter 3 times. You do not weigh the rice, you just throw it in the hopper. Make sure your moisture meter is always clean before you do your moisture. Throw the rice in here. You make sure your moisture meter is clean, there is no rice left in it, and then you throw your rice in. But before you throw your rice in, on the moisture meter, if you look on this chart, this is how you would set your different rice to get your moisture. With white rice, you would set it to key 1, page 2. This would be your reading for white rice. The first reading is 14.4. You unload the meter. Then throw in your next one. You load the meter. Let's see the reading here. second reading, 14.4. Our last reading, 14.3. Now you have the three moisture that you get, 14.4 plus 14.4 plus 14.3 equal to 43.1. 43.1. 43.1 divided by 3, because we need to take the average, divided by 3 equal to 14.3. You see on the meter there is a bias for the white rice, 1.3. We have to take away 1.3 from the 14.3. And we would get 13.0% moisture. That would be your moisture for the white rice.
This moisture rate is considered favorable and within the required rate. We now go back to the two 35-gram samples taken before. The broken grains from each sample are removed by using a jigger.
The next step is to do your grain length. The grain length is to be certain how much broken is in the sample. You draw 5 lines, and on each line you place 20 grains. No broken, tip to tip, no space, and at random. When you finish taking the grain length, you find the average of the 2 grain lengths from each sample. And the average grain length is what you would use to decide what is the broken grain length in your sample.
5 straight lines are drawn on a plain paper. 20 grains each are accurately lined tip to tip on each line, giving you a total of 100 grains, the required amount needed to determine the grain length. An indication is made at the end of each 20 grains for all the 5 lines. These markings will vary because not all of the grains will be of the same length. The next step is measuring the length of each of the 5 lines. A caliper is used to measure each line.
The caliper is 0 to mm. We're now going to take our grain length. You put the caliper where you start for its grain length to where you finish. Make sure the caliper is on both lines. You read the reading on the caliper. The first one is 142.23 mm. That is the first 20 grain length. Close your caliper. Make sure it is 0. You take your second grain length. Your second grain length. Put the caliper on the 2 line where you start and where you finish. Make sure the caliper is on the line. 147.01. You won't have the same grain length because remember, we take the grains at random. Close your caliper. Where you start, where you finish. .77 mm. Put your caliper, make sure it is 0. Second one. This is the 4th grain length. .141.49. And the 5th grain length. This is mm. 0. Restart. Refinish. 141.27 mm. As you can see, the grain length varied because the grains was picked up at random. But then you got to add up this 100 grain length and find the 3/4 grain length, because 3/4 grain length, any grain above the 3/4 grain length will be considered whole grain. If it is, or the 3/4 grain length would be a whole grain. Any grain below the 3/4 grain length is a broken.
The same process is applied for the second sample. The final figure of finding the 3/4 grain length for both samples is finding the average. In this case, the average grain length is 5.43 millimeters. This is considered whole grain. The next step is to analyze the sample. This is manually picking out the total broken grain from the sample.
Any grains that I'm not certain about, I'll put one side to measure with the caliper to see if it's a 3/4 grain or a broken. That is where I'm going to use my grain length. Now these I'm not certain about them, so I use the caliper to measure them. This grain is broken because it's 4.89 and our 3/4 grain is 5.43. So this would be broken.
The percentage of broken grain is now calculated. The broken grains are weighed, and that is the figure the percentage is calculated on. The same process is repeated for the second sample.
Total broken 5.48 grams. Our working sample was 35 grams, so we divide by 35, multiply by 100 to get the percentage of broken in rep 1. .48 divided by 35 would be a percentage of 15.6. This is the amount of broken, the percentage of broken in rep 1. 15.6%. For broken going to Jamaica, the sample is going to Jamaica. The brokens to Jamaica is 25%. And this is below, so this is a good sample. I'm now going to analyze for the factors in the rice. The white rice, when you're analyzing white rice, you look for striated red, amber, yellow, foreign matter, damage, chalky, paddy.
Amber is discolored grains. Chalky is the extra white grains. Paddy is the unshelled grains. Yellow grains are exactly what it says. The grains appear yellow in color.
Striated red is red corners in the cargo rice. When you polish it, you leave with red streaks on the grain. And the damage is heat damage, insect damage, or mechanical damage to the grain.
All of these unwanted rice grains are weighed for each of the two samples. This is to determine the percentage of its presence in the rice. As you can see, the grading and certification process is time-consuming, but it is required for all rice and paddy for export markets. Paddy, however, must be shelled before analyzed. We will look at this process next week as we continue to examine the quality control aspects of rice and paddy production in Guyana. Thanks for watching, and do remember to join me next week for yet another edition of the Science of Rice. Goodbye.